This video is the first in my Kinematic series. We're going to be learning about kinematics. It's
all the way from England.
Kinematics might sound a little scary, and I know you're probably thinking,
You shall not pass!
and probably also,
Has to go well. Okay, I'm scared for my health.
Okay.
But maybe, just maybe.
you'll be alright. Roll the intro.
Do you feel the vibes?
Let's start with a number line. I could say that my position starts at x equals 0. This would be my x initial. I could then go to any other spot on the number line. So here, my x would equal 3. This is what we mean when we're talking about position. It's just where you are along the number line. Now, staying in one spot on the number line is not particularly exciting. So what we're going to do here is move from x0 to x equal 3 over the course of, let's say, 3 seconds. This would give us what's called a velocity. Velocity is equal to the change in our position divided by the change in time. So in this case, the change in our position would be 3 minus 0 divided by the change in time, which would be 3 minus 0. So we get, we'll call this meters and seconds, so we would get 1 meter per second if each of our numbers represents 1 meter along the number line. This is how much our x is changing in time. If I wanted to graph my velocity and my position, I could make a graph of my position. So what I would do is here I would grab this and make a coordinate plane. This might be my x position, and this might be the time. So here we have 0 and 0. This is my origin. Here I would have 3 seconds. Here I would have 3 meters. And my slope of this line would just be 1. That's because my velocity is equal to my slope. Because my velocity, if you notice, is the change in x over the change in time. The change in x over the change in time is the same thing as rise over run, or the slope on this particular graph. That means that I can write an equation for x using y equals mx plus b in order to find the slope and intercept of my graph. So we already determined that x naught was 0, so I could say that x is equal to v, in this case x is going to be t, plus b, which is going to be x naught, which for our graph is 0, because I already told you that we started at 0. This is an equation for a constant velocity. But what happens if my slope isn't a constant number? For example, what if I had a graph that looked like this, with my x constantly increasing in time in such a way as this? Well, my velocity would be the tangent line at any individual point. But as you may notice, this velocity is changing in time. And this is what we call acceleration. Acceleration is a changing velocity in time. This relates to the concavity of the graph. Concavity is just which direction, if you made the graph a cup, would the cup be facing. So this is concave up, meaning that the acceleration is positive, since the up direction here would be positive. If we had something like this, the concavity would be down. That means that we would have a negative acceleration. So here a is less than 0, and here a is greater than 0. This is what we mean when we talk about acceleration. Now, I can write an equation for my position based on acceleration. This would give me my first kinematic equation. I get x final equals x initial plus v naught t This part stays the same from before. And now we add on our acceleration, 1/2 at squared. Now, since the acceleration is just the change in velocity with respect to time, I could make a graph of my velocity with respect to time. And my acceleration would be the slope of this line. So that means that I can make another kinematic equation, Vf equals V naught plus AT. This gives me 2 out of my 3 kinematic equations. The third kinematic equation is gotten by plugging one of these equations into the other one to get rid of our variable for t. So if we want to get rid of our variable for t, we need to solve one of them for t and plug it into the other. So I'm going to solve this equation for t since it's easier. So I get Vf equals V naught plus AT. I can subtract a V naught from both sides and get Vf minus V naught equals AT. And therefore t is equal to Vf minus V naught all over A. Then I can plug that in to my other equation up here, and I'll get x final equals x initial plus V naught. Well, now I have a t, so I have to put Vf minus V naught over A, and then I get a plus 1/2 A, and then t squared, so Vf minus V naught over A quantity squared. If you want a further explanation of how this works, you can look at my derivation video, but this will effectively, if you expand it all out, cancel out the constants into the algebra, you'll get V final squared equals V initial squared plus 2a times the change in x, where this change in x is just x final minus x initial. Since we'll often call x initial 0, this would just be your final position if you do it this way. So now we're left with 3 kinematic equations. The first kinematic equation is x final equals x initial plus V naught t plus 1/2 a t squared. The second kinematic equation is V final equals V initial plus AT. And the third is V final squared equals V initial squared plus 2a delta x. These make up the core of the kinematics unit. We'll be using all 3 of these equations to solve different variables, to find out how fast things are going, what distance they can travel, and at what times these events occur. Keep in mind that these things are all graphable, right? So your position can be graphed as position versus time, x versus t. The slope of this gives us our velocity, and the concavity gives us our acceleration. If we graph v versus t, the slope gives us our acceleration. Something very interesting is that the area under the graph gives our x. So if I have a v versus t graph that looks like this, the area of this triangle here can tell me my change in position. So that's a different way that you can use these graphs in order to tell you how to get different variables. That said, we'll mostly be using these 3 equations, and we'll be able to figure out all sorts of information. We're going to cover most of that in part 2, where we're going to go through some examples and really show you what these variables mean. So stay tuned. Right now, you might be a little rattled, and you may be going,
The quality and the quantity?
or may be worried that,
You're overcooking my grits, coach.
but don't worry.
What? Timmy, you haven't done anything yet.
Hopefully by the end of this series, you'll be having that
Light bulb.
moment. So just stick around, check out the other parts. Part 2 will go over some examples and things. Thanks for sticking around. Don't forget to like and subscribe. This case, my students might actually see it in their feed and maybe watch it, which would be great. All right, appreciate it.